Hello, Bernhard here. I'm an agronomic research scientist, and today I want to talk about a trial that the agronomy research team is conducting looking at soybean branching at different plant populations. In recent years, there's been a lot of discussion about the potential to increase soybean yields by planting at populations below 80,000 plants per acre. The idea is that the soybeans will compensate for the additional spacing between the plants and produce more branches that can set pods. This study we are conducting includes 4 varieties, 2 of which have been known to be more bushy or branching varieties. The populations are 60,000, 100,000, and 140,000 seeds per acre. This replicated research study is being implemented at 9 locations all across the Midwest. The yield equation for corn is the product of plants per acre, kernels per ear, and the weight of each one of those kernels. For soybeans, it's different because soybeans can branch. So instead of plants per acre, it is pods per acre. So it's the product of pods per acre, the number of seeds per pod, and the weight of each one of those seeds. Now, to keep math simple here, let's assume a grower typically plants 120,000 seeds per acre. If they were to reduce their plant population to 60,000 seeds per acre, that means each plant will need to double the amount of pods it sets in order to maintain that same yield potential as if you were going to plant 120,000 seeds per acre. When thinking about grain fill, the soybeans planted at 60,000 plants per acre will need to fill twice as many seeds as the soybeans planted at 120,000 plants per acre. However, physiologically, those plants at the lower population should have more vegetation, be healthier, and have more access to resources due to the reduction in plant-to-plant competition. One thing to be cautious about when planting at these reduced seeding rates is the potential for poor emergence. If planting at these lower populations, it is critical to utilize a full seed treatment that includes both a fungicide and insecticide to reduce the potential for seedling diseases and other pests. In addition, it's probably a good idea to use a pop-up starter to increase your chances of achieving your desired final stand. I pulled a soybean plant from each of the 3 populations, so 60,000 on the left, 100,000 in the middle, and 140,000 plants per acre on the right. Here's a closer look at the plant that was pulled from the 60,000 population, and you can see that it is loaded with pods. It also has a complete branch right here, one going this way and another branch going this way, and both of those branches are loaded with pods as well. Here is the plant pulled at 100,000, and you can see that it also has quite a bit of pods. It does have one other main branch coming off, not quite as many pods on that branch. And here is the plant that was pulled from the 140,000 population. And it doesn't have quite as many pods on this plant. It does have 2 smaller branches. Each of those branches don't have very many pods on them themselves. Another difference between these 3 soybean plants is if you look at the soybean planted at 60,000 plants per acre, you'll notice that it is a shorter plant because there's more spacing within the row, and so there's less plant-to-plant competition, so the plants don't have to try and outcompete each other as much, so they're typically a shorter plant. Also, you'll notice that the internodes, or the length between 2 nodes, is a lot shorter. Again, they don't have to grow as tall compared to the soybeans planted at 140,000 plants per acre. You'll notice that that plant is typically a little bit bigger, a little bit taller, because they're trying to outcompete each other, outgrow each other. And you'll notice that the internode length, again, the length between 2 nodes, is a lot longer for the plants at 140,000 plants per acre. Here I pulled the pods off the 3 soybean plants. When planted at 60,000 plants per acre, there was 149 pods. At 100,000 plants per acre, there was 85 pods. And at 140,000 plants per acre, there was 75 pods. So planting soybeans at a reduced population of 60,000 plants per acre will produce a lot more pods per plant. However, again, it will need to produce at least double the amount of pods to maintain the same yield potential as the highest seeding rate of 140,000 plants per acre. And again, keep in mind that also grain fill is an important factor in this, and can these plants fill all those additional pods? Check back in at the end of the growing season to see the final yield results from this study.